Good morning, myself Vikas. Today I am going to explain about data flow diagram of ARM processor. Introduction to ARM processor architecture. ARM processors are family of reduced instruction set computing architectures used in wide range of applications from mobile devices to supercomputers. The architecture is designed to be energy efficient, making it ideal for portable devices within with limited power resources. ARM processors are known for their simplicity, low power consumption, and high performance. Keyframes. Thumb to instruction set allows for both 16-bit and 32-bit instructions, improving code density and performance. Trust zones, Trust zone technology provides hardware-based security features to protect sensitive data and application. N- Neon SIMD engine accelerates multimedia and signal processing tasks by performing multiple operations in parallel. Overview of data flow in ARM processor. During the fetch stage, the ARM processor retrieves the next instruction from memory. Decode. In the decode stage, the ARM processor decodes the fetched instructions and determines the operation to be performed. Execute. During the execute stage, the ARM processor performs the specified by the decode instructions. Read back. During the read back stage, the ARM processor reads the result of the executed instruction back to appropriate register or memory location. Fetch stage. The fetch stage is first stage of the ARM processor where instructions are fetched from memory and prepared for execution. Steps involved in the fetch stage. Program counter is increment to point the next instruction address. The instruction address is sent to the memory management unit to translate the virtual address to a physical address. The physical address is then sent to memory unit to fetch the instructions from memory. The fetched instruction is stored in the instruction register for decoding and execution. Decode stage. The decode stage of ARM processor is responsible for decoding instruction and preparing them for execution. This stage follows the fetch stage and precedes the execute stage. The decode stage involves the following steps. Decoding instruction. The instruction fetched from memory is decoded to determine the operation to be performed and the operands involved. Register file access. The decode stage accesses the register file to read the values of register. Branch calculation. If the instruction is a branch instruction, the decode stage calculates the branch target address based on the branch offset and the current program counter. Execute stage. The execute stage of ARM processor is responsible for executing instruction and performing calculations. It involves the following steps. Fetch instruction, decode instruction, perform calculations, store result. Memory stage. The memory stage of the ARM processor involves accessing and manipulating memory. This stage is essential part of processor's operation, as it allows data to be stored, retrieved, and modified in memory. Fetch data, store data, modify data. Write back stage. The write back stage is final stage in ARM processor's pipeline. In this stage, the results of executed instructions are written back to memory or registers. Write back to memory. If the instruction is as modified memory, the results are returned back to the appropriate memory location. Write results to registers. If the instructions as modified registers, the return back to the appropriate registers. Conclusion. Clarity in data movement. The DFT provides a clear visualization of how data flows within the ARM processor architecture. The pathways through which information travels, facilitating a comprehensive understanding of the system operations. Identification of components. By delineating the distinct components and processors with the ARM processor, the DFT aids in identifying key elements contributing to its functionality. This segmentation allows for targeted analysis and optimization of individual components. Insight into interactions. Through the depiction of data interactions, the DFT illuminates the interplay and among various components. Understanding these interactions is crucial for ensuring seamless communication and coordination with processor. Thank you.